Today we are going to talk about the division of fractions. First of all, let us consider how a fraction is to be divided by an integer. If we have to divide the fraction 2 divided by 3 by the integer 2, we simply just divide the numerator of the fraction by the integer that we want to divide the fraction with. So in that case, we simply say 2 divided by 2 divided by 3. And well, 2 divided by 2 is just equal to 1. And we just leave the denominator alone. So we end up with 1 divided by 3. Okay, that was the first example. And another example is that if we have the following case, we say 6 divided by 7 divided by 3. In that case, we simply divide 6 by 3 and we'll leave the denominator alone. So we end up with 2 divided by 7. Everything is fine in this regard as long as the numerator is divisible by the number proposed. But very often it is not the case. Therefore, keep in mind that a fraction may be transformed into an infinite number of other expressions, and in that number there must be some by which the numerator might be divided by the given integer. If it were required, for example, to divide 3 divided by 4 by 2, so say we have the case 3 divided by 4, we want to divide that by 2. Well, we cannot do as we did before. We cannot just say 3 divided by 2 and leave the denominator alone. So first of all, what do we have to do? We have to multiply the fraction by 1, such that we end up with a numerator that can be divided by the integer. Well, if we say 2 multiplied by 3 divided by 4, this is equal to 3 divided by 4, because we simply just multiply it by 1. 2 divided by 2 is just 1. Okay, so that is just a cheap trick that we use in mathematics. Sometimes we multiply something by 1. So if we want to find a numerator that can be divided by 2, we simply just say 2 divided by 2 multiplied by 3 divided by 4. Then we end up with 6 divided by 8. And we want to divide this fraction here by 2. We simply have, well, 6 divided by 2 is equal to 3. So we end up with 3 divided by 8. So this fraction over here, this fraction divided by the integer, is actually equal to 3 divided by 8. Okay, so in general, if it be proposed to divide the fraction, say, a divided by b by c, we simply change it into a c divided by bc by multiplying the c divided by c, which is 1 again. So we multiply the fraction over here, a divided by b by 1, which is c divided by c, in order to have the c in the numerator such that we can divide the numerator by the integer c. Well, in that case, we divide by c. So we divide ac by c and divided by bc, and c cancels out here. So we end up with a divided by bc. Well, you might think that process is a little bit tedious, and I agree with that. So another way we can think of it is that when therefore a fraction a divided by b is to be divided by an integer c, we only have to multiply the denominator by that number and leave the numerator as it is. So for example, 5 divided by 8 divided by 3, we simply multiply the integer here with the denominator in the fraction. And well, that is equal to 5 divided by 8 multiplied by 3, which is equal to 5 divided by 24. Great. So that is a small rule. We can just simply multiply the integer by the denominator in the fraction in order to divide a fraction by an integer. Okay, so it now remains to show how one fraction may be divided by another. And here we remark first that if the two fractions have the same number for a denominator, the division takes place only with respect to the numerators. For example, say we want to divide 3 divided by 12 by another fraction, say 9. No, sorry, let me try for another example. Say we want to divide Let me come up with an example. Yeah, well, it is evident that if we take 3 divided by 12, well, 3 divided by 12 are contained as many times in 9 divided by 12 as 3 is contained in 9. That is to say, 3 times. And in the same manner, in order to divide, say, 8 divided by 12 by 9 divided by 12, well, what do? We simply ignore the denominators because the denominators are equal. So we just simply divide the first numerator in the first fraction by the second numerator in the second fraction. So this is equal to 8 divided by 9 because the denominators are equal. So we just look at the numerators in the fraction. Okay, so for the last example, let's see what happens when the fraction don't have the same denominators. For example, suppose that the fraction, well, a divided by b, suppose we have the fraction a divided by b is to be divided by the fraction c divided by d. Well, that is a little bit difficult with the tools we have currently learned, but another thing is that we can still just multiply each fraction by 1 in order to have something that we can divide the denominators by. So what do I mean? Well, let's try with an example here. Say we want to divide the fractions by each other. We want to divide a divided by b by c divided by d. What do? Well, let's try to multiply a divided by b by 1. And what do I mean? Multiply by 1, I mean d multiplied by d divided by d multiplied by a divided by b is equal to a divided by b, because we just multiply by 1. But that is also equal to a d divided by db. Okay, so now we have a denominator in the first fraction that looks like db. So actually we want to have the same over here in the fraction c divided by d. What do? Well, we simply say c divided by d multiplied by 1. In this case, when I say 1, I mean b divided by b, because that is equal to c divided by d, which is equal to cb divided by db. Okay, so the fractions here are actually equal to a db divided by cb divided by db. And well, we have the same denominators here, so we simply just divide the first numerator by the second numerator, which is equal to AD divided by CB. So AD divided by CB is equal to A divided by B divided by C divided by D. Okay, so actually there's another rule which we can follow, might be easier to remember. And the rule is that multiply the numerator of the dividend by the denominator of the divisor, and the denominator of the dividend by the numerator of the divisor, then the first product will be the numerator of the quotient and the second will be its denominator. For example, if we're going to divide, say, 5 divided by 8, we want to divide that by 2 divided by 3, well, that's actually equal to, we just flip the second one, we flip the second fraction, so actually that is equal to 5 divided by 8 multiplied by 3 divided by 2, which is equal to 15 divided by 16. Okay, great. So that is the rule we can remember. We can just flip or inverse the fraction. So if we want to divide one fraction by another, we just flip the second fraction and we multiply them out. So let me give a practice problem, say practice problem 1. Say we want to x plus a, we have the following fraction x plus a divided by 2x minus 2b. And we want to divide the fraction right here by the fraction x plus b divided by 5x plus a. Well, in that case, we simply just flip the second fraction, we inverse it, minus 2b, and we multiply it by 5x plus a divided by x plus b. And well, that's equal to x plus a multiplied by 5x plus a divided by 2x minus 2b multiplied by x plus b, which is equal to 5x squared plus xa plus 5xa plus a squared divided by 2x squared plus 2xb minus 2bx plus 2b squared. Okay, and we can probably reduce this a little bit. I suppose we can do that. Yeah, well, 2xb minus 2bx, it just cancel out. So, and well, xa plus 5xa is 6xa, so we have the following fraction over there is equal to 5x squared plus 6xa plus a squared divided by 2x squared plus 2b squared. Sorry, that should be minus. There's a minus sign here. We remove here and we say minus.